Okay, now we're moving on to Passport to Advanced Math. So this is lesson 1, which is function notation. This is Passport to Advanced Math 13, which is use function notation and interpret statements using function notation. So you guys all hit function notation a lot freshman year. So a reminder of what function notation is, it's another way of representing the y value of a function. So instead of saying y equals, right, we say f of x equals. Both of these you have to understand represent outputs, right? So why do we use function notation? For a couple of reasons. One being it's meant to be a precise way of giving information about the function without rather lengthy written explanations, right? And what it means is when I see f of x, f represents the name of the function. It basically tells you what your output represents. Whatever's in parentheses, x, right, basically is your input value. And we basically, identify it using a variable that makes sense to what the input represents. Okay? So basically with this, a lot of these questions are a mixture of no calculator and calculator, and they use graphs and algebraic expressions. So let's look at a couple of examples here. So the first one, the graph of y equals f of x is shown in the xy plane. What is the value of f of 0? So basically, what is the output when your x value is 0, or your input? So if I input 0, what is the output, right? So f of 0 in this case, when x is 0, y is 4. So f of 0 is 4. Okay? Now the next one, the function h is defined above. What is h of 5 minus h of 3? Well, what it basically tells you to do is evaluate this function when x is 5, you evaluate the function when x is 3, and then subtract the two. So real quick, h of 5 is 2 to the 5th power, which we know is 32, because 2 times 2 times 2 times 2 times 2, right, gives me 32. And then h of 3 is 2 to the 3rd, which is 2 times 2 times 2, which is 8. And right away now, h of 5 minus h of 3 is going to give me 32 minus 8, which is 24. So the next one, I know we've hit this one before, right? But I do want to reiterate this one because it's pretty important. So if f of x equals negative 2x plus 5, what is f of negative 3x equal to? Basically, everywhere I see an x, I'm basically taking this value and replacing x with it. So negative 2 times negative 3x plus 5. Negative 2 times negative 3x is positive 6x plus 5, which is letter B. Now, the next example. A function f satisfies f of 2 equals 3, f of 3 equals 5. A function g satisfies g of 3 equals 2, g of 5 equals 6. What is the value of f of g of 3? So basically, right, the first thing we want to do is evaluate g of 3. What is g of 3? G of 3 is 2, right? So what we're going to basically do is say g of 3 is 2. So what now is f of 2? Well, if I go here, the value of f with an input of 2 is equal to 3. So that is what you would get. So these are called composite functions. And the last one, the complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? So notice here, they're all giving you the name of the function, and then these represent the inputs. So what we want to do is find out which x values give us an output of 1. So an output of 1 means where are the y values equal to 1? Well, this has a y value of 1, this has a y value of 1, and this has a y value of 1. So if I go to f of negative 4, if x is negative 4, is y 1? Yes. How about 3.5? Or sorry, 3 halves. Well, that's the same as f of 1.5. If I go to an x value of 1.5, does that have a y value of 1? Yes. If I go to f of 3, 1, 2, 3, an x value of 3, does that have an output of or a y value of 1? Yes. Therefore, letter D, 1, 2, and 3, right, are equal to 1.